Hello students, welcome to TRK tutorial. In this video, we are discussing about matrices, all basics. Basics nothing but all definitions, formulas and concepts. So the basics are very lengthiest topic in this matrices lesson. So we divide into minimum two parts. So first part this video and next part will come after one day, right? So matrices basics. First of all, we discuss about the definitions. The first definition is matrix. First definition is matrix. Right. The first definition is matrix. Matrix means we can arrange some elements in rows and columns. Then we get a form. That form is called matrix. Example, suppose A, B, C elements. So and 1, 2, 3 E, F, G. These are some elements we form in rows. This is rows, okay, and columns. So we can arrange some elements in rows and columns. Then we get a form. This form is called matrix. So this is first row, this is first row, this is second row, this is third row. Generally rows denoted by capital R. So this is first row, we can write R1. This is second row, R2. This is third row, R3. Similarly, this is first column, C1. This is second column, C2, and this is third column, C3. Right? A definition, repeat again. We can arrange some elements in rows and columns. Then we get a form. That form is called matrix. Generally, matrices are denoted by capital A, B, C, so on. So matrix are denoted by capital A, B, C, and elements are denoted by small alphabets. Alright. So this is a matrix definition. Definition repeating again. We can arrange an ordered rectangular array of elements is called matrix. Simply we say that we can arrange some elements in rows and columns. We get a form. That form is called matrix. So symbols are capital A, B, C. So next definition is order. Order of matrix. Order of matrix. So let A be any matrix. We can write some elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a matrix. So in this matrix, number of rows, now counting 1, 2, 3. Number of rows are 3 and number of columns also 3. So this matrix order is 3 by 3. This symbol we can read as by or cross. This symbol we read as cross or by. Okay, 3 by 3. Or read as 3 cross 3. So 3 means number of rows. This 3 is number of columns. So order definition, order formula. Number of rows cross number of columns. So this is known as order definition. Next, we will discuss about types of matrices. types of matrices. Types of matrices. Matrices is a big lesson. So basics also very useful to learn the matrices chapter perfectly. So now types of matrices. The first type is square matrix. Square matrix. Right. Square matrix definition. Some example, this is a matrix. I am writing like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix. In this matrix, now we count that how many rows are there? 3 rows. How many columns are there? 3 columns. 3 rows and 3 columns. Order is 3 by 3. Whenever a matrix have number of rows and number of columns are equal, number of rows and number of columns are equal, then that matrix is called square matrix. If number of rows not equal to number of columns, then that matrix is called rectangle matrix. So once again, if in a matrix number of rows and number of columns both are equal, then that matrix is called square matrix. If number of rows and number of columns are not equal, then that matrix is called rectangle matrix. Some example. So observe here 1, 2, 3, 4, 5, 6. This is a matrix. Now we write order of this matrix is number of rows is 2 and number of columns are 3. So by observing here clearly 2 and 3 are not equal, so that this matrix is called rectangle matrix. Next concept is trace. Trace is, first of all, trace is possible for only square matrix. Trace is possible for only square matrix. So right, how do we find trace? First of all, let A is any of the matrix. We take 1, 2, 3, 4, 5, 6, 7, 8, 9. In this matrix, this 1, 5, 9 elements is called principal diagonal elements. 1, 5, 9 are called principal diagonal elements. So the sum of trace definition is sum of principal diagonal elements is called trace. Repeat again, sum of principal diagonal elements is called trace. So now trace of A, trace of this matrix is 1 plus 5 plus 9, that is 15. 15 is called trace of this matrix. So now square matrix, a rectangle matrix. So principal diagonal is what we discussed about that already. Now trace. Trace means sum of all principal diagonals is called trace. Next definition is diagonal matrix. Diagonal matrix. So right, diagonal matrix definition. So clearly observe the definition name diagonal matrix. So ఇక్కడ నేములోనే మనకు దానికి డెఫినేషన్ ఉంది, డయాగ్నల్ మ్యాట్రిక్స్. సో ఫస్ట్ ఆఫ్ ఆల్ ఐఎమ్ గివింగ్ ఏ ఎగ్జాంపుల్ ఆఫ్ డయాగ్నల్ మ్యాట్రిక్స్. 2 0 0 0 5 0 0 0 9. So this is known as a diagonal matrix. What is the definition of diagonal matrix? Right? What is the definition of diagonal matrix? So observe here, in a square matrix, first of all this is square matrix. In a square matrix, all non-diagonal elements are equal to 0. Non-diagonal elements. So 2, 5, 9 are diagonal elements. 2, 5, 9 are diagonal elements. These are all non-diagonal elements. So diagonal matrix definition is, in a square matrix all non-diagonal elements are equal to 0. Then that matrix is called diagonal matrix. So next definition is scalar matrix. Scalar matrix. Next definition is scalar matrix. So first of all I will give an example for scalar matrix. After that we discuss what is the definition. So example, scalar matrix. Example 5 0 0 0 5 0 0 0 5. So this is known as a scalar matrix. Okay, now definition, observe here. Definition is, this is principal diagonal. Okay, this is principal diagonal. Now the definition of scalar matrix is, in a square matrix, clearly observe here, this is a square matrix because number of rows and number of columns are equal. So this is a square matrix. In a square matrix all non-diagonal elements are equal to 0. All non-diagonal elements are equal to 0, and diagonal elements are equal to each other. Diagonal elements are equal to each other. Then that matrix is called scalar matrix. Okay, right? And next definition is unit matrix. Unit matrix. Unit matrix or identity matrix. Identity matrix. Unit matrix or identity matrix. This definition is very important in board of intermediate exam, IPE exam, for 2 marks. 2 marks question. This is a very important definition. Unit matrix. So first of all I am giving the matrix 1 0 0 0 1 0 0 0 1. This is called unit matrix. Other name is identity matrix. So how do we define? How do we define unit matrix? Simply, in a square matrix, so clearly it is a 3 by 3 order, 3 rows, 3 columns, right? This is a square matrix. In a square matrix, the definition started. In a square matrix, all non-diagonal elements are equal to 0. Non-diagonal elements are equal to 0 and diagonal elements are equal to 1. Diagonal elements are equal to 1 is called unit matrix or identity matrix. So usually the identity matrix is denoted by capital I. So here this is 3 by 3 order. So this we write as I3. For one more example, I2. I2 means we write 2 by 2 order matrix. 3 by 3 means I3. 2 by 2 means I2. I2 nothing but 1, 0, 0, 1. This is also unit matrix with order 2. This is also unit matrix of order 3. So I. So now a simply very useful one of the concept is some example 1, 2, 3, 4, 5, 6, 7, 8, 9 is any one of the matrix. Any one of the matrix. Generally matrix elements are denoted by small a. Small a. A is any one of the element. So this is first element. First element we write like A11. A11. A11 means this one represents first row. This one represents first column. That means this is a one symbol A11. So 1 is first row, first column. Next 2. 2 we write as A12. 2 we write as A12. That means 2 situated in the first row and second column. First row and second column. That is 1, 2. Now 3 situated at first row and third column. That is 1, 3. First row and third column. Similarly 4 is second column, second row and first column. That is A21. 5 is A22 and next one is A23. Similarly A31, A32, A33. So these are the symbols of the matrix elements. So 1 means A11, 2 is A12, like this. Okay. So now here this formula applying for this one, right? This concept is applying here. So like here, this is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a matrix. Now observe here, comparing this identity matrix with these elements, right? Corresponding elements are equal. First of all, so this value is 0. That means this is 0. What is that here? Observing A12 is 0. A12 place element is 0. And next number is A13 is 0. Right? And this is also A23 is 0. And this is A21 equal to 0. And this is A31 equal to 0. A32 equal to 0. From comparing these two matrices 1, 2, 3 elements are 0, this one also 0, only diagonal elements except remaining all elements are 0. So A12 equals 0. Here actually Aij is the element symbol. Aij is element symbol. I denote row and J denote column. Okay. Aij is any of the element. I represents row, J represents column. So this is I, this is J, I, J, I, J, I, J, so on. So here this is I value 1, J value 2. clearly I1 J2, so these two numbers are not equal. Also here this is 1 is I, 3 is J, so not equal. Here also I not equal to J, so on, so on, so on. So the definition of the unit matrix mathematical definition of unit matrix or identity matrix is for all I not equal to J, I not equal to J, then that element's value is 0. For all I not equal to J, that element is 0, and for all I equal to J, then Aij element value is 1. So observe here, this is I 1, J 1, Ij both are equal, this value is 1. I value 2, J value 2, Ij both are equal, this value also 1. I value 3, J value 3, this value also 1. So whenever Ij values are equal, then those elements values are 1. Then that is the unit matrix. So mathematical definition. So now the definition of unit matrix or identity matrix, repeat again. So first of all, in a square matrix, all non-diagonal elements are equal to 0 and diagonal elements are equal to 1. That is called unit matrix or identity matrix. Next, that mathematical definition of unit matrix or identity matrix is for all in a matrix, for all I not equal to J, then Aij value 0. If I equal to J, that element Aij value is 1. That is called definition of the unit matrix or identity matrix. Now the next definition, null matrix or zero matrix, null matrix or zero matrix. First of all, I am giving an example 0 0 0 0. This is an example for null matrix or zero matrix. How do we define this matrix? Simply, in a matrix, all elements are equal to 0. Then that is called null matrix or zero matrix. So it is denoted by O. Okay. So one more example, 0, O equal to 0 0 0 0 0 0 0 0 0. So this is also one of the example for null matrix or zero matrix. Simply, all elements in a matrix, is 0. Then that matrix is called null matrix or zero matrix. The next definition is row matrix. Row matrix and column matrix. Row matrix and column matrix. Simply, the examples of, first of all, row matrix is 1 2 3 4. This is the one of the example of row matrix. Now the definition of row matrix is, in a matrix only one row is there. In a matrix only one row is there, then that matrix is called row matrix. Now one of the example of column matrix is A, B, C, D. So this is a column matrix. column matrix. In a matrix, only one column is there. Only one column is there. Then that matrix is called column matrix. So horizontal line is called row, vertical line is called column. Only one row is available there, that is called row matrix. Only one column is there, that is called column matrix. So next definition is upper triangular and lower triangular matrices, right? Triangular matrices. Triangular matrices are two types. First one is upper triangular matrix. Second one is lower triangular matrix. Triangular matrices are two types. First one is upper triangular matrix and second one is lower triangular matrix. So now first of all, upper triangular matrix, upper triangular matrix and lower triangle matrix. So right, this is also one of the important definition in IPE level. So first of all, I am giving an example for upper triangular matrix is, right, observe here, upper triangular matrix example giving now 1 2 3 0 4 5 0 0 6. So observe here, by joining these three zeros we form a triangle in lower side of the matrix. So this is the example of upper triangle matrix, upper triangular matrix. Similarly, I am giving a example for lower triangle matrix, just quite opposite of this matrix is. So observe here, right, lower triangle matrix example is 0 0 0 1 2 3 4 5 6. By joining these three zeros we form a triangle. This triangle is above side of the matrix. This triangle formed at above side of the matrix, but this is matrix name lower triangular matrix. So here a triangle formed downside of the matrix, downside of the matrix. This matrix is called upper triangle matrix. Now definition about these two formulas is, right, formula applying concept A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is a matrix. Now comparing these three element values from this matrix is, first one A21 value is 0. So observing here, A21 value is 0 and A31 value 0 and A32 value also 0. A21 value 0, A31 value 0, A32 value 0. So here this is I value, this is J value. I not equal to J. Also I greater than J. This is greater than to this value. One is minimum value, 2 is big value. So A21, 2 is I, 1 is J. Clearly observe here, I greater than J. Similarly here also, this is I, this is J, here I greater than J. So here also I greater than J, I greater than J. So definition is for all I greater than J, then Aij equal to 0. Aij equal to 0. So upper triangular matrix definition is in a square matrix for all I greater than J, then Aij equal to 0 is called upper triangular matrix. Similarly here, now comparing this concept also this matrix now. So observe here, A12 value 0, A13 value 0, A23 value 0. So here A12 value 0, A13 value 0, A23 value also 0. So in the suffix values, first value is I, second value is J. So I less than J. So here also I less than J. Here also I less than J. Now the definition of lower triangular matrix is for all I less than J, then Aij value is 0 is called lower triangular matrix. Now definition repeating again. In a square matrix for all I less than J, Aij equal to 0 is called lower triangular matrix. In a square matrix for all I greater than J, then Aij equal to 0 is called upper triangular matrix. Okay, thank you.